but he's absent. But there you go. There's your notes catching up. Here we go. All right. B, find all times when the particle changes direction. If it changes direction, then what do you know about the position, the velocity, or the acceleration? It's one of those three components. Where would I look for when it changes direction? Velocity changes sign. So you would find where velocity changes sign. You would say where you looked. You wouldn't just say, here it is. It says to justify your answer. So this is why the numbers I'm going to get are what they are. It's because velocity changes sign at, and it looks like there are, I don't think there's one in there. I feel like that's probably two numbers there, yay? So you need to analyze the graph. And typically I would read ahead to find all the possible parts of a problem. But isn't it likely that we're going to need that number again? So I would store that I'll store the first one A. 1.772, is that what you got for the first? Okay. And store 2.506 to B. Okay, I remind you, report 2 or 3 decimals or more in your work. It doesn't matter if you're random or truncate. 1.772, 2.506. 1.772, 2.506. Is it 506 or 576? Okay. Are there time units on this? Second. These are seconds. So what are the acceleration units? I didn't put units on my first part. What were the acceleration units? Units per second squared and units per second. This then is seconds. All right. Total distance. We've done that quite a bit, but it's worth reviewing because it's super duper important. Distance versus displacement. How do you find distance when you are given a rate? What do you integrate? Velocity or absolute value of velocity? Absolute value of velocity, also known as speed. You integrate speed. How fast, or how far are you going? I don't care which direction. Use the speed, not the velocity. Displacement is change in position. That then means you do want to incorporate signs, so velocity. However, there are sometimes cases where velocity is positive on the interval. Then you would say something like, because velocity is positive on the interval, this integral, which normally is just displacement, is both displacement and distance. If the velocity is positive, then the absolute value or non-absolute value, they're the same. And so it's distance and displacement. You're only moving right, so your displacement and your distance are the same. All right, so then in this question, would you try that on your own, show the appropriate work, and we will check answers in a minute. Please, on the AP test, if they gave the velocity the name v, then you don't have to keep writing it in the integral. So it's a time waster on the test to actually write the function. Just call it v, right? I tried it in the graph, but they shaded it. It looks super, but where's the notes there?
It's right above that's down the 1.7.
That's the area? Is it? Is that the net area? Is that what you guys got for your integral? Oh, I didn't, oh, wait a second, I don't want the integral of velocity, I want the integral of absolute value. And I don't have that graph, so never mind, sorry, I don't, why would I be doing it? Okay, so, shift plus 0 to 3. It's distance, not displacement, so we want absolute value. Absolute value is in the menu next to the 9. Boom. And you can pull up the velocity function, which I called f, and x, and boom. You get 4.6579. All right, then. Express the integral with limits. Absolutely make sure you have the absolute velocity, or absolute value, excuse me. And then report the value to 3 decimals, 4.6579, or more if you like. 4.6579. What are the units there? Is it meters or units? Units. Okay, that's distance, so that's units. All right. Would you now try, find, and interpret? Try D, please. Try D. That one I think you can do on your own. That's not too new. One point 6315. So did you get 1.6315? Okay, put yourself in the shoes of a grader. Somebody said this is the displacement of the, whatever it is, what is it, particle? Of the particle. Good enough? No. How about this is the displacement of the particle from time 0 to time 2? Still not good enough. No units on either. So, nope. You should have 4 things. This is the displacement of the particle with units. What are the units? Particle in units from time 0 to time 2 seconds. What if somebody said it's the position of the particle at time 2? Why is that false? It's the change in position, but it doesn't take into account where it started. All right, to find where it is, you'd have to take start plus change, and that means d dash d dash. All right. What about the last one? You might feel like it's the same question. It's not. Do the last one, please. Oops. Okay, so what's the difference? Velocity is always positive in that region. So it's not only the displacement, it's also the distance. And you need to say that. There's a point built in for that. So it is the displacement in units, and because velocity is positive, also the distance you still need to make reference to the time frame. In units from time 0 seconds to 2 minutes. Okay? All right. We go through E. Okay? Let's go to F. In this case, the function is not easily integrated. In fact, it cannot even be integrated unless you know infinite series. So, not everything can be integrated. If I asked you to write an expression involving an integral for the position at time t, give that a go, please. Give that a go. Let's see, what else would I see? 1, 2, 3, there's one more, what else would it be? All right, whatever, good enough. Which of those is correct, red, blue, or green? Okay, red has a fault to it, why? Yeah, you've used T in two different ways, okay? You're, first of all, saying position is up from starting point till whatever time you asked for, but you're then also using t as the independent variable in the velocity. That's not okay. You're using t in two different ways. Okay? You must use what's called a dummy variable. That is not okay. That's bad math. Don't do that. So this person's saying, all right, I'll use x for a dummy variable. Is that okay? No, x is already used in some other way to indicate position. So definitely don't use x as a dummy variable. Use anything else. I used u, use w, whatever you want, with certain exceptions. Obviously don't use e or something ridiculous or o. That's just stupid. Okay? All right. Let's go to this. During the time, this one's a bit of a gotcha. This was on an AP question a couple, 4 or 5 years ago, and it was a gotcha. During the time interval from 0 to 3, what's the greatest distance between the particle and the origin? Show the work that leads to your answer. Now this is going to be good practice, first of all, because although some of you are absolute masters of extreme value theorem or absolute extreme, but some of you not so much. So this is the greatest distance, capital D. And that means it is an absolute max. Okay? Absolute max what? This is the hard part. Distance, okay. So what measures distance from the origin? X? Yes, no. Okay, let's go here. Here's particle 1 at 2. Here's particle 2 at, or particle B at -3. Which one's further from the origin? -3, all right. So the absolute max distance really means what's the absolute value of the x part, all right? Now don't worry, we're not going to have to take absolute value. We just need to figure out what are the numbers, and then we'll say, all right, forget the negative, forget the positive. So the absolute value really doesn't come into play till the end. So don't sweat that too much. All right. So to me, there's 4 parts of an absolute extreme problem. First, you state the EVT. The absolute max must be at critical number or an endpoint. Here's the first place a lot of people made mistakes. Critical numbers. Critical numbers. I have probably now it's reached epidemic proportions, and I have about half the people saying, here's my critical numbers. Boom. Trust me. No, I won't trust you. You will tell me where the critical numbers come from. I beg you, I've told you a million times, you cannot just report the critical numbers. You must say where you went to find them. They are when? What? Okay, so we want critical numbers where the derivative is 0 or undefined, right? And this time we're talking about the derivative of position, which is velocity is 0 or undefined. You've got to say that. If you don't say that, then they don't give you credit for finding where it happens. You must say where you found it or where you looked, not just what they are. So we have those already stored. Velocity was 0 at 1.772, which I have stored as A, and 2.506, which I have stored as B. You follow? So I'm going to report those. 1.776, and I can't remember the other one. 2.507. Okay? All right. So I state the EPT that, hey, this is where I'm looking. Second, these are my candidates, the endpoint 0 and 3 and the critical numbers. Now I need to find the value at each candidate. Now by value I mean the X value. That says candidate, by the way. Okay, X, the candidates are T at 0, 3, 1.776, and 2.507. Those are the candidates. X at 0 is given. What is it? 24? -1? What is it? -1, isn't it? Didn't it start at -1 on the number line? Okay. I could say, hey, X at 3 is the starting position plus the change in position. And if nowhere in my previous work had I said, this is how I'm going to find position, then I would have to say that. But this is not necessary because in the previous problem, the previous part, I said, this is how you find position. So it's established. I have a formula for finding all positions. You don't have to show the work on that. You can just, people assume, oh, you use this to find your X values. So would you tell me what is X at 3 using that idea of the initial -1 plus the change in position or displacement gives you ending position? Plus 0 to 3 function x. Did you get position at 3 was 0.729? Yes? Okay. 0.729. Now find it at another candidate. 1.776, which I have stored as A. If you just, in terms of time on the AP test, if you just go back and recall that and type over the 3 with an A, 0.8948. Do you agree with that value? That makes sense. I'll talk about why that makes sense in a minute. 2.507 is my B. Go up, recall that, and go from 0 to B time frame, -0.569. Right. You can see there'd be a great IVT question in here. So, all right, so I have all 4 candidates. Do you need another minute, or shall we move along? You're good? Okay, so what is the greatest distance? Now the greatest distance means how far is any of these from the origin without respect to sign. So greatest distance from the origin really means remove the sign, so I'm going to use absolute value of my justification. Which of those, or what is the greatest distance from the origin? 1 unit, okay? So you would say on our conclusion, that's part 4, the conclusion is the greatest distance is 1 because, and I would say because the absolute value of negative 1 is greater than the absolute value of 8.948 is the next biggest candidate. It's greater than the absolute value of 0.729 is greater than the absolute value of negative 0.56. All right? Okay. Is this part of your? This isn't on yours. Okay, I'll leave it. All right. How about H? Do you have H?
Yeah.
All right. What is the particle moving toward the origin on the interval? What? It's different. What is yours say?
It's the particle moving toward the origin at t equals 2.6.
Oh, gotcha. At t equals 2.6. Just all right. Little more clear question. All right. Cool. How would you answer this? Is velocity enough? Why not? Say I found at time 2.6 the velocity was positive. Would that indicate that it was moving away from the origin? No. We also need to know. Yeah, we need to know position because if it was moving right at that time and it was right of the origin, well, yeah, it would be moving away. But if it was left of the origin at that point and moving right, then it would be moving toward the origin. So I would need to know both position and velocity, right? So would you calculate x at 2.6? How do you do that? We have a way to calculate position? Yes, we do. Our previous integral defined function of x initial start plus change 0 to t of velocity moving at 2.6. I got negative 0.492, so it seems just left of the origin in negative territory, right? Negative 0. What about then? What now do I need to calculate? Velocity at 2.6. Okay, how do I calculate velocity? Yeah, that's function 1. So just use the function in F1, which is the velocity they gave us at 2.6. I get 1.652. So what do we conclude? Moving towards the origin or away? Is it, first of all, is it starting left of 0 or right? Left. And is it moving left or right? Right. So is it moving towards or away?
Towards.
Yeah. So we would conclude the particle is moving towards the origin. And how do you justify it? Sometimes you kind of know the idea, but how do they want you to say it? What would you say? I mean, just throw it out there. Learn from your mistakes. If you got it wrong, you'd rather know that. Because, yeah, that's actually the best way to go is because x is less than 0 and velocity is greater than 0. Now, if you think because it's left of the origin and moving right, that's true, but how do you know that? Because x is less than 0. So your comeback would be you have to justify why you say that. And if you just go straight to the source of what's going on, that's what they really want. All right? Okay. How many times, if any, is the particle at the origin? Where should we look? There's one part of your answer here that will tell you all. Part G. Part G, I agree, 100%. Okay? Let's take these values in conjunction with the graph and the big picture and remember what's going on. So we know that up to Okay. Up to, what's that time? 1.772, it's moving left. It started at -1, it moved right until it got to 1.772. So didn't it pass through the origin once in that front? Yeah? And then it moved left from 172, from an x of positive to an x that's negative, so it must have been 0 then. And then back right, so it must have passed through 0 how many times? Actually, let me say it this way. It started at negative, right? This is the next point in time. The next point in time that was interesting was positive, so it must have passed through 0 once then, yeah? Then it went to this point in time where it went from a positive x to a negative, so it must have passed through 0 once then, and then it went from a negative to a positive at the end point, so it must have passed through 0 once then, so a total of 3 times. Now, if you did this in a college class, they'd be very picky about this because they would be reading for very specific words. You would have to say from time 0 to time 1.776, the particle moved monotonically, which is to say one direction only, which is why you can say it went through 0 exactly once, not at least once, exactly once, and then exactly once. Let's talk about how to say this well then. You would say, first and foremost, if we're going to use IVT, let's meet the condition. Position is continuous. Particle, let's see. So let's go with something like, what's a good way to say this? Help me out, people. At time equal 0, x is -1, and at time equal 1.776, x is positive, what is it? 1.775? 895. And if I were you, I'd parenthetically say his velocity is positive on the whole interval. So by IVT, x must equal 0 once in that first time frame. It moved right only from -1 to positive 0.895, so by IVT x equals 0. Similarly, at time equals 0, at time equal 1.776, x is 0.895, but later at time equal, what's the next time? 507, x is negative 0.567, 9. Velocity is negative, so by IVT, I should say between these, x equals 0 once in that time interval, 1.776 to 2.507, and then one more time, and we're done. From time equal 2.507, x equals negative 0.569 to x equal 3 when time equal 3, time equal 3, x equals, where does it end at? What's the last value at x equals 3? 0.729. Velocity is positive over the whole interval. By IVT, x equals 0 once here in that interval from 2.507 to 3. So we would conclude that x equals 0, 3, and that is exactly, not at least. Okay? Yeah, now that seems like a lot of writing. There's been at least one mean value theorem where it's like, it's triple that. It'll be fun. We'll talk about that later. All right. That is that. Do we have time to go over the test? Well, let's see. What do I have tomorrow? Is tomorrow better day to go over the test? I'm trying to think. We've been doing nothing all weekend, and we'll continue to do nothing. It feels like I'm so busy for doing nothing. What's my plan? Sorry, I didn't even. That's how passive you guys are students. You just move around and show up. I had a call for and Friday is
Literally in my How long so besides too?
we're so busy. Can we go over the text in 8 minutes? Last lesson. All right. Homework questions. Oh no, we gotta go, baby. We're fine. 2 days. 8? 19. 19, 22, 13, 25. Did you say 23?
They're not 13.
Yes.
Yes, 13. 78. Okay. I will say this just in passing. I don't get a lot of people coming in 7th hour from this class, which if you're doing great, that's fine to be expected. Just keep doing what you're doing. But if you are dropping F's on a test, why are you not my little 7th hour buddy right now? You know what I'm saying? You should be in a lot. But that's just maybe I need a breath mint. I don't know. Here we go. 7819. Is that still a question? Is it different in any way or straight up normal? Straight up normal. Okay. 19. This is going to be. Okay, these are those skill problems that we need to either keep doing to keep your skills where they're at, or some of you improve your skills. There were a handful of people in the test that didn't use the product rule, didn't know the quotient, didn't know the changing. That cannot be. We have to kill the technique questions. So this is a technique practice question. It's important that you copy the right questions, because that's for tonight's one. This is a different question. Sorry, never mind. Forget that lecture. I'll give it to you tomorrow. That's tomorrow's question 19. Good thing I caught it. I'm sure you would have let me get through all the way through it. That's no problem. All right, so here we go. F of x is the absolute value of cosine of x. P of x is x squared. Negative 3 pi over 2. 3 pi over 2. And h is the composition G composed on F. That's the same as G of F. If F goes into G, we would get the absolute value of cosine of x squared. Okay, let's do a little cleanup on that. First of all, you might have been confused because of the absolute value. Can I make my life easier and just say that absolute value, all right, it would make all things positive, but wouldn't the square do that anyway?
Yeah.
So isn't this the same as that? And the answer is yes. For all x, that would be exactly the same. The difference is calculus-wise, the second one's a heck of a lot easier to do derivatives on than sweating the absolute value part. All right, so this, if I want to graph the function h, oh no, find the equation of h, there's h, and determine the zeros. Zeros are where cosine equals 0, and that's at, when is cosine 0? In this interval. Isn't it at any kind of pi over 2 or 3 pi over 2, you think?
Yeah.
So negative 3 pi over 2, negative pi over 2, pi over 2, and 3 pi over 2, yeah? Okay. B, if I go to graph this then, the graph will have zeros. I'm going to make my scale pi over 2. We know it has zeros at negative 3 pi over 2, negative pi over 2, pi over 2, and 3 pi over 2. We also know that because of the square, it'll never be negative. And because it's cosine, it's still going to max out at 1. So the question then is this because the absolute value, does it do this kind of thing, this boop-de-boop? And the answer is no, it doesn't. Right? There are not hard flips at those zeros. The square makes this differentiable. The derivative exists everywhere for this. If they ask me for the derivative, then I will be good to go. There's no places where there's a sharp turn. The curve actually looks more like this. It's smooth there. Locally linear. All right, they should all have the same aspect. All right, so the domain and range of H. That's part C. The domain, is there any reason you couldn't put any x into that? Like a 0 in the denominator, or a negative in a root, or a log of a negative? None of that's true, so x is all reals. Or, I guess, negative 3 pi over 2 to 3 pi over 2 if they restrict. There's no restrictions other than the ones they gave. Okay? What about the range? The picture helps if you have a graph, and the y is obvious. What's the range of y values? 0 to 1, and it is inclusive. It does touch those, so that's brackets. Find the equation of the tangent at 3 pi over 4. Tangent line, point. Well, the angle is 3 pi over 4. What's cosine of 3 pi over 4 and then square? So what's cosine of 3 pi over 4? Negative root 2 over 2, and then square it is 1/2. Okay, 2 is 1/2. Okay, the slope is the derivative at 3 pi over 4. I wrote 1/4. Sorry. Okay. Thank you. The derivative, what's the derivative of cosine squared? Please, I beg you, use the chain rule. Okay, it'll be 2 cosine to the first, and it'll be a
Good morning,
negative
Dublin Jaguars. Please rise for the pledge of allegiance.
sine.
Ready, begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
All students, did you lose a ring in the library? Come to the library to describe the ring to the claimant.
For students who participated in the 2018 GE Girls Summer Camp, and for others that are interested in science,
I get
technology,
1, yeah?
engineering, and math, GE
So
invites
y
you to join
minus
their
1
first
equals
Camp
1
College
times x
Informational
minus 0.
and goal-setting meeting Friday, February 8th, during 7th hour in Miss Newcomb's room. During these sessions, you will get the opportunity to interact with teachers and students from the Colorado School of Mines.
You will also get to experience fun science and engineering activities during 7th hours throughout the semester. Don't miss out. This is open for girls that are in grades 7 through 12 and will be first come, first served. There'll be a paper sign on the to come
Oh,
just you
never mind. Sorry,
sign
that's
up on
dumb.
February 7th.
Sorry, my
Tickets
tangent.
are now available for the spring musical curtain. So many times get the cast and production team of the new musical Robinson. Good thing Detective Frank Chaffee is out.
There you go.
Oh yeah, maybe solve a murder or two.
22, yes, no?
Online at DevlinMusicals.biz. Student tickets are $8 up the door, and Thursday night's performance will include a raffle for prizes.
Okay, A, B, and C, or just
Here at the basketball game. Check it out. Have you ever wondered how the yearbook gets made? It is
so you're not sure about your derivative, your slope?
For only $0, you can enroll in yearbook and decide which one of your friends you can put in the book for the whole school to see. If this catches your interest, please sign up for the meeting on Wednesday, February 6th, and come to the yearbook interest meeting in the library. We hope to see your fun, funky, fresh faces there.
Is it
Senior
replaced?
high students, high school spring athletes. The athletic
did you say was the
online
book?
registration window is now
Okay.
open. Please register for your spring sports by February.
Oh, just kidding.
Thank you for your
That's, what is it?
students interested in AP Computer Science. There will be an informational meeting in
That's the
computer on
derivative.
FE 202 during
There are
7th
a
hour,
lot of
Thursday,
people in
January
this that did
31st.
not
Don't
recognize
need to sign up for
the
7th hour prior. There will be a paper sign up at the
breaks my heart.
Hey, sophomores! If you're interested in taking AP US history, there'll be an informational meeting this Monday. Sign up for 7th hour with your history teacher, then proceed to the auditorium for a free informational meeting. Girls tennis players, there will be an interest meeting Monday, February 4th during 7th hour in the auditorium. All girls planning on participating, please come to the meeting.
13?
It'll be a boys'
What's 13?
Thursday, January 31st,
That's not hard.
7th hour in the cafeteria. Want to win free stadium tickets? Submit pictures of your stadium proposals to
It's just tangent, isn't it?
and picture with the most comments wins. Go Jack.
Hey, 25?
Steve Bowler will be in counseling during the 7th hour with all students who apply.
25
What
is
are
a
your
good one.
next steps? Get those questions answered about housing, scholarships, and more. Science counseling for juniors and sophomores are out below. Any students interested in taking
All right.
AP art, there will be an informational
The
meeting today during
range
the
of
period
this.
or if there's any one
What comes out of this?
what AP art is all about.
When you give our tangent, you give answers from
It's this Saturday from
negative pi over 2 to pi over 2, inclusive or not?
Either way, get your stadium tickets for
Not inclusive.
during lunch and 15 cents. See you Saturday.
And so, as far as what kind of values you could get, sign goes from -1 to 1, but because it's not inclusive,
Tickets are $5 and must be purchased during lunch on Thursday and Friday outside the cafeteria. Don't forget to just your wish we share.
23, yes, no?
They are $12 a piece. So by art, for the wish wall outside the cafeteria. Our goal is to fill the wall by the end of the week. Also, come to Picnic Express and it's full of activities near Devlin. That's all the announcements. Have a great day.
Make sure you use the product rule carefully on that middle guy. First stays the same, derivative the second. The second stays the same. Oops. Have a good day. I'll see you later. Part C might be hard. Yes.
Gee, do you want me to pick her?
Yeah. Hi. Violation of impact.
It's fine. I would tell her anyways.
Yes.
I'm done. Oh my. I was really close. Yeah.
Like 4 and -6. And the area of the curve must be less than 0 and -6 in the middle. And this price is unusual. This would be less. So, because it has a higher -6 and a much base bonus, this value would be like 8.
Is that Pokemon?
The integral of that must be greater than -18. And
No,
this
it's a disappointment.
It's compact.
So, it has to be between -18, whichever one satisfies that condition. Okay, this is unnecessary. This is true, I know it has to be less than 2.
And so we have gone for their
I need to get at least one from Turkey from you. As long as it is. Yeah. So if you turn them away from this, that's fine. Okay, sounds good. Hi. Oh, I forgot. I didn't get my blanket, I didn't get. Freaking day. Oops, recording that.
I asked you where yours is.
No, where's your